This is Carl Franklin here from the comfort of my kitchen. Um, I'm actually not in Tahiti, even though that's what this scene would tell you. Um, it's a green screen, but I figured, let's just all imagine that we're on a beach, hanging out together, drinking some cocktails that have some fruit punch in them, maybe some rum, maybe a little more rum, maybe brought to us by beautiful people, and we got a band playing. And I've just told the band to take five so I can talk to you. So let's we're just imagining here. This is what I'm hoping will happen. So let me share my screen again, and we'll get started. So this screen right here is it's a PowerPoint slideshow that I have that all my Blazor code is wrapped up in this thing I'm doing called the Blazor Desk Show. So don't mind the subtle branding. I just wanted to say welcome. In this hour, I'm going to share everything I know. Well, almost everything I know. If I talk really fast, I'd be able to share everything I know, but it is an hour. But this is the thing that I want you to take away, the hands-on lab and the slideshow. Both of those things are available at blazordeskshow.com. So if you just go up there, you can actually download a pretty big project that you can, steal snippets of code for. You don't have to worry about, snapping screenshots and URLs and all of that stuff, even though I put them here in the slideshow. So I'm going to start by talking about what Blazor is. Blazor started as a little WebAssembly project that Steve Smith did right here at NDC, but in Oslo, a couple of years ago. And people just went nuts. They just went absolutely crazy when they saw the possibility that we could have C# running in the browser again. And of course, everybody asked the question, is this Silverlight vNext? And the answer is no, it's not. I actually wrote a little blog post about it, which you can see. I got a link here. The difference between WebAssembly and Silverlight, and I can understand why people conflate Silverlight's past with Blazor WebAssembly's future. It's because that they both kind of have the same end result, right? They both allow developers to write C# code that runs in the browser. But the difference is so vast and it's so different. Okay, so here's the difference. Blazor ultimately failed because, I'm sorry, Silverlight ultimately failed because of the plugin model of the browser, which was really the only way that we could have code that wasn't JavaScript running inside the browser. The plugin model was causing all sorts of problems for iOS. And most notably, Flash was draining the batteries of iPhones and iPads because it was so CPU intensive. And it was also, the plugin model was also a vector for malware. And so for the first time, Apple customers were experiencing malware. And of course, they dogged on Microsoft for years about being, just insecure and all of that stuff. And they prided themselves because of that app store model on curation and strict standards and stuff. You can just run an app that you download off the internet. So anyway, Steve Apple Steve Jobs, he said in essentially a blog post that was called Thoughts on Flash, that no more iOS, no more plugins in iOS. So iPhones, iPads, they would the Safari browser would not use and wouldn't load plugins, any plugin. So Silverlight was a casualty of that. Now, WebAssembly, which is just a couple of years old, is this binary virtual machine that's cross-platform that lives in every browser. And I'm talking every browser. Okay, not every browser, because there's a lot of browsers that they were popular for a while, and then for whatever reason, development stopped on them, right? Internet Explorer being one of them. So even the latest version of Internet Explorer, which is 11, doesn't support WebAssembly because they just stopped developing for it, right? But every other browser, and especially the ones that you use today, even Safari on iOS, they all support WebAssembly. So that is sort of the backstory of WebAssembly, and that became the backstory of Blazor. But along the way, Steve Sanderson and co. Essentially developed this component model, and the component model is really what Blazor is all about. Because when you write markup and code for Blazor, that same markup and code can run in two different hosting models. One of them, obviously, WebAssembly, runs in the browser, but the other one is a server-side Blazor, which runs all the code on the server, which is interesting, right? It's sort of an answer to web forms, I guess you could say, but the difference is going to be really obvious when we start looking at the traffic and looking at the magic behind how that same code is going to run, that runs in WebAssembly, is also going to run on the server. So you really have to pick a horse, but I'm going to show you a technique by which you can belay that decision and actually develop both hosting models at the same time. So you really don't want to, nor can you, nor would you want to combine models. All right. This is a SPA framework. So this is a single page application UI framework like Angular, like React. And you wouldn't pick like a version of Angular where all the JavaScript ran on the server versus on the client and mix them. Like that's what we're talking about here. You wouldn't mix them. It's really a UI framework. It's not an architecture for building a SPA application. The only part of that architecture that's different is where that code is running. Everything else will be exactly the same. All right, so now that I've got the what is it out of the way, let me talk about how to install it. Well, if you just install the latest Visual Studio 2019, not preview, not anything, and regular .NET Core 3.0, you're going to get Blazor server support right in the box. That has been baked since Core 3.0 was shipped. But WebAssembly is still in preview. And if you want to run WebAssembly, you need to get the latest version of Visual Studio 2019 preview. Even the free community edition is just fine. You don't need to spend any money, but you guys are probably all professional developers. You probably have MSDN, you probably have enterprise. That's just fine. But the community edition does everything that you need to do. You install the latest .NET Core SDK 3.1. All right. And then you install the Blazor WebAssembly template. And it's a command line thing that you just run. And if you just Google Blazor WebAssembly, Blazor WebAssembly getting started, or WebAssembly Preview 3 now available, that will also show you exactly what you need to do to install it. All right, so what I'm going to do is talk about the server-side model and then the client-side model, but we're not just going to talk, we're going to actually look at the network traffic and see what it is. So the model is for server. The magic that makes this happen is SignalR. I'm just going to go over to my code and create a Blazor application. I'm going to call this Blazor server, and let's get the right location here. So because I've installed the template, I have the option of also doing a WebAssembly version. And hey, if you've installed the template and you don't see this, here's a little trick that I just learned yesterday or the day before. Switch back to .NET Core 3.0 with this dropdown and then back to 3.1, and you should see it. The latest version of Visual Studio 2019 preview is still a little wonky, but there's workarounds. So Blazor server app is what I'm going to create. And we're just going to run the application because there's a little demo built into the template. and you'll get to see what that looks like. You've probably seen this, and yeah, this is another issue. Just sometimes you'll have to run it twice. You might have to build it. Um, it's nothing to worry about. Just Visual Studio. And the other thing I wanted to say about the WebAssembly version is that it is syntactically baked right now. The syntax of the component model isn't going to change between now and when WebAssembly ships. So you can be safe, and rest assured that when you build your Blazor WebAssembly code, that code is going to run. The underlying plumbing code might change a little bit, all right? But that is going to be baked in May. And then WebAssembly is going to be part of .NET 5 shipping in November. So I've got a counter button. This is one of the 3 demos here. Here's some static information. Here's a counter button. Notice that it also reset to 0 when I navigated away from it. That's going to be important later. And then I've got an example of fetching data from either a service that's local or an API if we're using the WebAssembly template. So let's just look at this code while it's running. I'm going to go to my pages folder, and you see counter.razor. So that is a Blazor component that is actually a page, and you can tell it's a page because it has the @page at the top with the route. So you can see here, I've got very simply some HTML here, this @sign, this Razor syntax. You should be already, if you've done any kind of Razor, you should be used to that. We're displaying this variable, but the variable is defined in this code block right here in the page. Yes, you can move it out to another class, but it's right here in the page. And we've got this variable right here, current count, and a method, increment count, that just, increments it. We get there with this button, and the @sign tells you and Blazor that this is a Blazor server-side, whatever, a Blazor component model directive. It's not, if I took away that @sign, that would be a JavaScript on click right here, right? So that's a JavaScript directive. This is a Blazor directive. So there's no run @ server. There's nothing. It's very, very concise. And I love this about the component model, is that it just works so well. But as you can see, I can put a breakpoint here. And when I click the button, boom, I got the breakpoint. Now this code is running on the server. Wait a minute, this is the client, this is the server, right? So I've defined the markup, but this code is running here. How did that happen? Well, let's take a look by pressing our friendly F12 button, and I'll go to network. I'm going to disable the cache. You can probably see right there. Just make sure there's no caching happening. And I'll start recording, and then I'll press Control F5, and we'll see what we get. All right, so that is all of the HTML, CSS, JavaScript, whatever, that was sent down. But look at this guy right here. I know you can't see that, but that's a WebSocket. This is SignalR. This is essentially a SignalR connection. And where it came from is defined here in this Blazor server JavaScript that runs in the browser. All right, that's sent to the browser, and that hooks the DOM elements. And then when I click the button, that hook happens, and it says, oh, this is a server directive that I need to call. It sends a message via SignalR to the server. The server says, oh, on click increment count, I'm going to run that. Server runs that, and look, this affects the DOM. How do I know? Well, the server has a graph of the client's DOM in memory. Every single client, it keeps a graph of the DOM. So there's no view state going back and forth like there was with web forms. It already has a graph. It knows what the state of the DOM is. So it notices that there's a difference. And it says, well, I'm going to take the diff, and whatever changes, I'm going to send a binary message back down to the browser to update the DOM. and all of that stuff happens. Now, how do we know that? Well, let's click on this, and we'll actually see the messages. As I click, right there, you can see 290 bytes went up to the server. That's the green arrow. 148 bytes came down, and then 27 bytes. I'm assuming this is a thank you very much. I got it. Everything is updated. You know, maybe this is another the latest graph of the DOM. I don't know what that is actually, but I do know how you can find out. If you want to see, I have a blog post here, and you can just go to blog.appvnext.com or look in this the PDF, which is linked at the server for this link. I show you how to log the SignalR traffic and actually look at it and see what's going on, not just the amount of data. But look at this. Look at how much data was transferred initially when I refreshed that page. 146K. That is pretty cool. All right. So I want you to just see what's going on here. This is the magic. The magic is happening with SignalR. Now that SignalR hub that is being used here isn't something that you can tap into. It's not something that you can hook yourself to do your own kind of, chat rooms or other typical SignalR applications. But this is just an ASP.NET 3.1 Core 3.1 web application. Excuse me. So you can, hang on a second. So you can add a SignalR capability to it, and it isn't going to interfere with this one. So this SignalR hub that's built into .NET Core 3 for Blazor server applications is just a one-to-one. I mean, there's a hub, but it's only allowing one-to-one communication between you, the client, and the server. So there isn't any one-to-many stuff going on here, and it's very tightly controlled, and you don't have access to it for good reason. So let's talk about scaling, because obviously if everything's on the server, there's going to be a certain amount of memory required for every client, and it turns out it's about 85K right now, or last time I looked anyway. So it's not a whole lot, but if you're planning on supporting 20,000 users, you might have to beef up the memory and the CPU of your server. So you don't want to keep millions of rows of data in memory for every user. This is standard stuff when you're thinking about conserving memory. So you do have overhead per client. WebSockets is another precious resource that will run out eventually based on the amount of memory and CPU available. But what you can do is you can scale out with this SignalR service. Let me pull this over here. So Azure has a SignalR service, and you can use that and completely remove SignalR from your server to scale out. And there's this GitHub has all the magic tools for doing that. So this right here is a screenshot from a presentation Dan Roth did at .NET Conf, and they did a test. Microsoft did a test for appropriate latency, which they deemed was less than 200 milliseconds, added for handling the UI under a load. And this was a real application. It wasn't just a counter. They built an application, and they wanted to automate clicking the buttons and seeing what the latency was as they turned up the number of users. So it turns out with one virtual CPU and 3.5 gigs of RAM in their setup here, they were able to support about 5,000 active users. If they up that to a virtual CPU server with 14 gigs of RAM, 20,000. Now that was without using SignalR service, Azure SignalR service. That was just in the box. So memory is the primary bottleneck. I'll talk in a minute about having multiple servers or a server farm or a cluster and what's required for that. So let's talk about the ups and downs, the drawbacks, the benefits and the drawbacks of Blazor server hosting model. Download size is small. The app takes full advantage of the server because it's all running on the server. So anything that you can do in an ASP.NET core application, you can do on the back end. Thin clients are supported. So WebAssembly if WebAssembly isn't running in that particular browser, and I'm looking at you, Internet Explorer 11, there is actually a required polyfill to get it to work with Internet Explorer 11, but that's easily solved. Some companies are still using that because it isn't modern and because their software isn't modern. So this may matter to some people. The app's C# code base is not sent to the clients, so they can't see the code that's running. My answer to that is that's actually not a benefit, nor is it a drawback. It just is. The rule for me is I don't put anything on the client that I don't want the client to see. And that's true whether it's JavaScript or Blazor or whatever. So the downsides of Blazor server, there's a little latency added for the round trip to SignalR for that SignalR hub. There's no offline support. So if the client connection fails, the app stops working. Right? That's kind of a big deal. So remember, every UI interaction requires a trip to the server. And then scalability, we just talked about that. Memory state is what makes this possible, and we'll talk about that in a minute. And an ASP.NET Core server is required to serve the app. So you can't just package it all up like you can with HTML and JavaScript and serve it on a CDN. All right, I'm going to switch over to, what do we call this, Slido, and see if anybody's got any questions. That's app.sli.do or sli.do. There's a link in the channel room, conference stream room 1. Any questions on server-side Blazor? Or does anybody want to just unmute their microphone and ask a question? That'll work too. All right, I'll take that as a no. Let's move on. If you have any questions, again, you can just unmute your mic and talk, or I'm watching Slido as well. All right, so let's talk about the client-side hosting model. It's a little simpler because everything's just running in the server. There isn't a client-server interaction. There is no SignalR hub for basic UI. Of course, if you're going to do your call into APIs, you're going to do that no matter where you're calling from. So as I said before, WebAssembly is the thing that makes this all possible. It's there. It's in the browsers. It's not going away. It's not insecure. It has the same security boundaries for your code that JavaScript has. And .NET isn't the only language that runs on WebAssembly. Rust runs on WebAssembly. Golang runs on WebAssembly. There's a growing list of languages that have compilers for WebAssembly. Think of this like a little virtual machine. It's its own operating system. There's even an initiative to move WebAssembly out of the browser and onto the desktop, which requires now an interface to the system that it's running on. And that's called WASI, WASI.dev, if you want to go there and keep your eyes on that. I think that WebAssembly is so revolutionary and so solves a problem that we've always had with the browser, which is JavaScript. JavaScript is by nature a problem for enterprise developers and was written in a weekend. And there's parts of it that really suck. And, there's a lot of people out there that use it just because it's the only game in town. Well, WebAssembly sort of blows the doors off of that and says, you know what, there's a lot of other languages that you can run in the browser now with the same level of security and efficiency. I've heard a rumor, I don't know if this is true, but somebody told me that the guys who built Docker said if they had WebAssembly in 2008, they never would have built it. Interesting, huh? All right, so there's the model. We're going to go back and watch the traffic with a WebAssembly application, which I will just add to this solution. I'm going to add a Blazor application. I'm going to call it Blazor WASM. And here's the old trick again. See, WebAssembly isn't showing up. I'm going to do that. Also, I'm going to check this off right here. ASP.NET Core hosted. What is the advantage of using Blazor at all? It is slower than WASM. It overloads the servers and it doesn't have cool features that JavaScript has, like support. And, I get this a lot. Why not just use JavaScript, man? I'm not telling you not to use JavaScript. I'm not talking to you. So right on with your Angular and your JavaScript and everything. Go for it. Just use it. All right. So this Blazor is for people, for developers, for corporations that have more C# resources than JavaScript resources. Or maybe they've found that getting people up to speed on all the JavaScript frameworks and all the libraries and the tooling and all that stuff, they have a lot of attrition. They have a lot of people that can't do it and only a few that rise to the top, and then those people get hired out. So there's definitely a shortage of programmers, but there's a lot of enterprise developers that ever since Silverlight went away have been looking for a way to leverage their skills on the web. So I think that's the largest audience for Blazor. But good question, Anonymous. All right, so ASP.NET Core hosted is an option that I'm checking off here. If I don't check that off, I get one application that just Visual Studio runs an IIS Express to the client, but I want a server also in that same URL space so I can do controllers and things. So that's what this gives you. So look at this. Looky here. I've got Blazor WASM server, which again is a server. It's got controllers for API controllers, and it hosts this client right here. This is going to run in the browser, but they both have access to this shared project, which is just a .NET Standard project. And this is got the models. So this is where you would put your models if you're using this kind of architecture. So let's look at Blazor WASM. And I'm going to set Blazor WASM server as the startup project. I'm also going to rebuild this because I know better. And we'll run it. And we're going to see it looks very similar. In fact, the code is almost exactly the same, but the difference is this fetch data right here in the Blazor server version. This is calling a local service, forecast service, which is injected into the page, and it lives here on the server in a data folder, and it's just returning some data. But on the client, fetch data uses an HTTP client, and it calls a URL. Now, it's a local URL. It's a relative URL, but that is the server. It calls into Blazor WASM server to the weather forecast controller, and this is an API controller. So the difference is architectural. but the code is exactly the same, especially for the counter. So speaking of the counter, I'll go here and I'll do a breakpoint. And there you go. This is new, just in the last few days. Now you can debug, but there are some limitations. There's a few debugging limitations. If you go out to that blog post that's linked on the first page, the getting started and what's required, Dan Roth tells you exactly what those limitations are. Debugging isn't complete yet, but at least you can, you can get there. You can get breakpoints. There are things that you can't inspect though, and things that you can't do. All right, so I'm going to continue here. Let's do what we did before with the server. Go to the network tab, disable the cache. There we go. Control F5. And let's see everything that gets loaded up here. Whoa, a lot of stuff. Six megabytes transferred. Yes, that's a lot. And that is because by default in debug mode, the linker is turned off. And if the linker is turned on, you won't get the entire WASM framework. And that framework, by the way, is right here. The CLR is called .NET WASM. Let me expand this a little bit so you can see the size. And the framework, the thing that's actually taking up the most space is not MS Core Lib, but where is it? Well, if I sort by size, you'll see. Yeah, MS Core Lib DLL, that's right, 1.3 megabytes. So if I turn off, and I can turn it off by going to release mode, or I turn on the linker. If you're in release mode, the linker is on. And we'll do the same thing again. Control F5. All right, now it's about a megabyte. So big difference if the linker is on. But look, these are all DLLs. So that .NET WASM is the CLR. That is and it's based on Mono. It's a Mono-based CLR. That is the binary, whereas all of the other code that runs are assemblies. And they're .NET 2 standard assemblies, which means a lot of stuff. Obviously, you can't do anything that calls out to Windows or to a system, but all the good stuff that you need to do UI is in there. And anything that's missing, you can just add a NuGet package to, and as long as it's .NET 2 standard compliant, it's going to run. So benefits and drawbacks of this model. The code executes more quickly in the browser, so there's lower latency because we don't have to go to SignalR just for basic UI interactions. You do have offline support, and progressive web apps are supported, and you even saw that when I created a Blazor WebAssembly application. There's a checkbox to enable PWA support. So that adds the manifest and it adds the service worker, and you can just go ahead and modify that to your heart's content based on what PWA does. Also, because it doesn't require that server to exist, it can be distributed via CDN. And as I said before, any .NET Standard 2.0 C# will run in the browser. So downsides. It can't directly access your database, just like JavaScript. You wouldn't send down in JavaScript a connection string to a SQL database, or a secret that's used, a password that's used to access Azure resources. You're not going to do that in that code. You're going to have to write an API layer. So you use the API. You call the API from the client. In the API, you can do whatever you need to do to kick off whatever processes on the server. So it's still in preview. It'll actually be in preview until .NET 5, but it will be baked plumbing wise in May. Right now, as I said before, the component model is baked. The component model isn't going to change. The syntax isn't going to change. So your code is shipped to the client. I have to mention this because somebody brought this up as a security concern. It's no more a security concern than with JavaScript. So you wouldn't run secret code, you wouldn't run your secret sauce, but you have an option. You can run that in an API on the back end. All right, other questions about Blazor WebAssembly hosting model. Oh, we got a whole bunch of questions in Slido. So let's see. Would you recommend Blazor for production usage, say deployment to Azure App Service? Well, I have to ask you a question. Which Blazor? Right now, I wouldn't put Blazor WebAssembly in production, but I would recommend Blazor Server. But here's the thing. You now know the difference between Blazor Server hosting model and Blazor WebAssembly hosting model. We've talked about the pros and cons. So now let's talk about where it's appropriate to use Blazor Server. I think that for enterprise developers who are doing business to business software, business to customer software, need to think about how many clients they want to support at the same time, and either make sure that they have one big server with Jagunda memory and CPU to handle that, or that they think about building a cluster, which now raises other questions about scale in state, right? So we're going to talk about state in a minute, but that has to definitely be handled. You have to manage your state. And while the tools there are primitive, they're easy to understand, but it isn't like session in web forms where you have like this prescriptive system that you can either store it outside in a server or in a SQL server. It's essentially up to you. You have classes, and those classes can be serialized to JSON and then stored wherever you want to store them. If you want to store them in a SQL server or in a Cosmos DB and spend all that money, go for it. But you probably want to think about maybe some of it in local storage right in the browser, and some of it outside on a document database or something that's a lot less expensive. But get it outside of your application. That's what you're going to need in order to do web farm kind of stuff. So if you can support that and you can count on the fact that your customers are using it in a scenario where you can count on the bandwidth, right? That would be good. I don't know as if this would be good for a Starbucks app. You know what I mean? Where, you know what I'm saying? Like you would, the PWA with Blazor Server, not a good idea, because you don't have the offline support and all of that stuff. You have to be connected. So think about those restrictions. And if you can check off all those boxes and Blazor Server seems to fit, then yes, I would recommend it for production. I have this question long, so I'll split it. For the WebAssembly solution, there will be some delay when you run the app for the first time. Yes, that's right. Server version does not have this drawback. Yes, that's also right. Is this possible to make your application start running on the server? Then all the assemblies are downloaded in the background, and when they're ready, the app switches to the WebAssembly. Does that make any sense? I'm not so sure it's a big deal. Like, I mean, what are we talking about? Up to 5 megs, up to 6 megabytes of data? Gmail is 5 megabytes in an initial download, and it is an initial download. It goes into cache. And just like with Gmail, you can clear the cache. And when next time you go, you're going to wait for a few seconds for it to load up again. So I don't think it's a big deal. I mean, any of these SPA frameworks, Angular, React, they all have the same issue, which is there's a whole bunch of stuff that has to get loaded the first time. Um, but there are situations like, for example, if your preferable model is WebAssembly, but you need to rely on the server version for Internet Explorer 11 and things like that, yes, you could do that. You could fall back to the server version, but it would be a different URL and all of that stuff. So you have some things to think about. Can Blazor be used as an isolated module in an existing ASP.NET solution without framing it? Yes, you can add Blazor pages to any ASP.NET 3.0, Blazor server pages to any ASP.NET 3.0 application. Easy peasy. All right. Let's move on. Good questions, guys. So let's talk about binding. Binding is very, very elegant in this component model. They've done a good job of making events very easy to understand. And I'm going to show you what that looks like now. Rather than sort of reading the screen to you, this is just a sort of a reference. Let's actually do this here. So I'm going to go back to Blazor Server as being my startup project here. And let's go to index razor. Just again, making sure this is all happy and isn't going to barf on me. Make sure we're back in Blazor Server. Oh yeah, I was in release mode. Let's go back to debug mode. You're going to get this a lot. Squiggles that go away in Visual Studio. All right, cool. So I think I've got in my toolbox some snippets. Yes, I do. So let's use these. Well, I guess it's a complete snippet. All right, so let's talk about binding. You've already seen one-way binding in the counter page, right? This is one way, meaning you're just displaying something. The two-way binding is where you have input. So now I'm binding this input tag's default property, which happens to be value. That's why I don't have to be explicit with that if it's the default property. I'm binding it to message, which is this property right here. And then I'm displaying that message in the top. So when I run this, it's in the input, and it's also in that H1 right there. Now, if I change it, I'll type changed. There's an event that triggers the UI update. By default, it's on change, which happens when we lose focus. So I'm going to hit tab, boom, and that on changed event happens. That's what tells Blazor to update the binding, update the values on the page. But I can change that event. I can say at bind, bind : event equals on input. And that happens with every keystroke. So now every keystroke is going to update the UI. There it is. So one simple change, and this event is now forcing that UI update. Now let's do something interesting, and let's add a component. I'm going to add a component into my shared folder. This is where shared components go, or non-pages. And this is just a convention, right? So I'm going to say I want a new razor component, and I'm going to call it child component. And you're going to see one of the latest Visual Studio Preview's best features. Yeah, not really. That's going to hang there forever. So the workaround is just close it, reopen it again. And we'll replace this with this particular code right here. So this is a component, doesn't have an at page directive at the top. And I've just got some inline styling here with a div. I'm giving it some padding, a light gray background color so that we know visually that it's a component. And I've got a parent message string property here and that I'm displaying there. And when I click the button, we're going to call update message. And update message is going to raise an event. So let's talk about parameters. All components, when they interact with their host, they interact via parameters. So this parent message parameter, think of it like a public property on a custom control. But it can be bound to, and it can be updated and all of that. Same with the event. So this event callback, I pass it, whatever the type that I want it to raise. And I call it message changed. And this is essentially an event definition. Now I'm going to raise it when I click the button. I'm going to set the parent message to Blazor and then call message changed invoke async. And by the way, any method can be async. Just make it async task instead of void. And then I can do things with await. So I'm invoking this and passing the parent message. Now back in the host, I'll change this code. And here I've got the same binding with bind event on input, but now I'm defining a child component and I'm binding the parent message property to my message property. All right, so when my message property changes, the parent message is going to change. When the parent message changes from below, my message is going to change. It's a two-way binding. And by the way, the event that is going to cause the change in the component is message changed. So when the message changed event gets raised, my message will get changed, and then it will be changed here and here. So look how slick that is. I didn't even need to have an event handler and to set values. I just used binding. Right? Changes up here, changes in the component. And when I change it from the component, boom, it changes me in the parent. Elegant, 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 beautiful. Love that. So let's talk about handling state. This is absolutely critical if you want to do a sort of a cluster application, right? Which is an economic way to scale out rather than having one Gigunda server. But let's talk about first getting state out of the page, and then we can actually move it out of the application. But that's beyond the scope of what I'm talking about. But you'll see just how easy it is. So in Blazor server, I'm just going to add a class. And I could do this in Blazor client as well, but we'll just pick server. App state. Doesn't have to be called app state. I'm just calling it app state. It has one property called counter. And now I want to add this as a service that I can access anywhere in my application. And to do that, this is in startup, in configure services. I'm going to add it as a scoped service. What's the difference between singleton, let's say, and scoped? Well, singleton services, of which the weather forecast service is one, there's one instance that's shared among all clients. All right, not good for state because it has to be a client by client access instance. That's what scoped is. So when you add scoped, now you're saying I need an instance of app state for every single client. So this actually manages the instantiation part of it. And now you can just inject it where you want it. And whatever that instance is, that's what you get. So I call @inject app state in the counter. And here I can completely get rid of this. And I can use app state .counter. Not sure why this is a little bit brain dead right here, not giving me IntelliSense, but I got a feeling if I just rebuild this or build the solution, everything's going to be fine. Yeah, worked just fine. Visual Studio has a little catching up to do. But again, this is a preview version of Visual Studio 2019. So as I said before, remember when I incremented the counter and I went back to home and or off the page and then back to the page, it had initialized to 0. That's because the page reinitializes on navigation. So just by moving this outside, into a scoped service, now I've moved it out of the page. So what do I put in here? Anything, whatever you want. So this is all stuff that you want to persist. This is your new session, if you will, or any scoped service. You can consider it session based. This is something that'll be available client by client. Now, in the server, what happens if that server goes down? What happens if they press refresh? Well, it's completely gone. But you can use, no, it's not here. You can use stuff like local storage to store stuff locally in the browser per client. And then, of course, you can use some database or anything like that. There is a great shopping cart demo that I have in a blog post you can check out. And this shows you how to use local storage to persist state. And it's just a little shopping cart demo that I did where you pick an item, you get to see the item, you put in a quantity, you add it, and then it shows you what's in your cart. And then if you close the app and go away and come back within 30 seconds, because that's the default time, it will still be there in the cart. And you can obviously change that from 30 seconds to whatever you want. It's just really to show you that you can put a little bit of stuff in local storage if you want to. But Steve Sanderson says anything really more than a couple of K, you probably should move that to a data store somewhere. All right, so this is the coolest thing, and looks like the last thing that I'm going to show you, which is a technique Steve Sanderson showed at NDC London earlier this year to develop both the client and server apps simultaneously. So I've got both a client and a server app in my project right here. And the first thing I'm going to do is add a project reference from Blazor server, project reference, to Blazor WASM client and Blazor WASM shared. All right, from the server to the client, not to this server, but this is where the code is. It's in Blazor WASM client. That's why I want to do that. Now, if I go into my servers _ host CS HTML, this is sort of the HTML shell that everything runs in. You can see that there isn't much here in the body. This right here is for handling errors. Here's the script. This is everything right there. This right there is your entire set, your compiled Blazor components. All your pages, your components, your code, all of it is right there. So instead of using my local app, I'm going to use Blazor WASM client app. And now what's going to happen is when I run the server, it's going to run on the server and all the code will run on the server, except the code is this code, the code that's in Blazor WASM client. So wouldn't it be cool if I could run them both at the same time? Well, I can do that by going to the solution properties, and I'm going to set Blazor's multiple startup projects, Blazor server to be one, and Blazor WASM server, remember, because that is hosting that guy. And just to show you that this is working, I'm going to make the crazy step of deleting the pages from my server-side Blazor app. And also I want to change the mode to server, not pre-rendered. Pre-rendering means that it's a server-side thing only, and pre-rendering means that it renders twice, once before it connects to your pages render once before they connect to the client and then once after, and I don't want that. So now I'm going to rebuild the solution. And we're obviously going to move questions offline because I've only got 4 minutes here. But after the solution is rebuilt, I can run this and we're going to get two browsers. Right? One is running on the server, Blazor server right there, you can see. And one is running on the client, Blazor WASM. But it's both of these are the client code. Now, is it going to work? Remember I told you the difference between fetch data? This one calls an API with a relative URL. This one calls a service. But now it's running on the server. It's got a problem. It doesn't know where that service is. Not only that, but it doesn't have an HTML, an HTTP component. So it's going to complain about that first. There's no registered service of type HTTP client. So in order to get this to work, you have to do two things. You have to inject, or not inject, but you have to add HTTP client to the server side environment. And when you go into the code for fetch data, you can't use a relative path here. So the actual path is here in launch settings JSON on Blazor WASM server. We get that SSL port right there. And now we can go back to fetch data and change this to HTTPS localhost colon this guy weather forecast, and now it should be able to call the API from both sides. All right, here's Blazor client. Oh, now Blazor client has a problem. And it's probably just because I got to rebuild everything. This happens a lot, you know, when you're developing. Just rebuild usually solves problems that don't here we go. So on the client, I can fetch data. On the server, now I can fetch data also. And folks, that is going to be it for me because I've got 1 minute to spare, but I'm going to take questions outside. I'll meet you in the hallway, but I'll also be in Slido. Okay. Thank you very much. And thanks to NDC for helping make this happen. And hi, Mads Torgerson.